Hey guys, welcome to today's class. Have fun.
So we're talking about pressure. Pressure. When we talk about pressure, all we're trying to say is pressure is the ratio between the force applied to the area upon which the force is applied. So you have a body which a force F is applied, and this body has its dimensions, the length and the breadth. So the force applied on the body affects the area in question. Let's say we have a tiny strip of this on which this force acts. So the force which acts here is dependent on the area of this strip here. So this gives us the relationship as the pressure force acting on a body either at right angle perpendicular to a body is equals to the force over the area. So the SI unit for pressure is Newton per meter square, because force is in Newton and area which is in meter square, or Pascal. So this formula is simply for calculating the pressure in solids, most solids. So also we have pressure in fluids. Fluids also exert pressures on their molecules and also on the walls of the container. So you have body of water. It's a body of water. Now the water has its density. The force of gravity acts on it. So you also have the height which this water contains, which the water covers in the container. So talking about pressures in solids, which is direct forces, the force over area. Whereas in case of liquids don't have definite volumes and shape, so they can't resist such pressure forces which solids can take. So in this case, it has to do with three parameters. So in this case now, the pressure on this liquid, the pressure in this liquid rather, is the product is also force over area. But in this case now, the force acting in this fluid is the product of the density, the gravity, the area, and the height. So on the division by A, we have pressure forces in liquids to be rho GH, rho which is density. So you should take note that pressure in solids equals to force over area. In fluids, is the density multiplied by the gravity multiplied by the height. So quickly, we are going to be looking at Pascal's law. Pascal's law is a very simple illustration of how pressure works in fluids. Pascal's law simply summarizes that a liquid transmits pressure equally in all directions. So I'm using this illustration here. Here we have a bowl or a container filled with liquid. Now let's imagine this is a tiny droplet of the liquid. Now this droplet of the liquid exerts the same pressure in every direction. So what it's trying to tell us is you have, say, the sea now. You apply, throw a body into here, and you throw another stone here. So what Pascal's law simply tells you that a fluid transmits its pressure in all directions. So the pressure this stone will be experiencing here is also the same as the pressure which this stone will be experiencing here, because a fluid transmits the pressure equally in all dimensions. So A liquid transmits its pressure equally in all directions, in direction x, in the y-axis, and also in the z-axis. So this gives us the pressure in the x direction is equals to the pressure in the y direction. It is also equals to the pressure in the z direction. So we'll be looking at applications of pressure. But before I look at applications of pressure, I have to talk about some properties of pressure in liquid. So you have a body of liquid fluid, let's say water. So water, which is standard fluid. So we're able to establish that the pressure at any point in the liquid is transmitted in every direction. So that's one of the first properties of fluid pressure. The pressure is transmitted equally in every direction. Another property is the pressure is the same. The pressure at the point below the liquid is proportional to the depth. So what are we trying to say? You have this body of water, and this is height 0 meters. This is 5 meters. This is 10 meters. You place an object here, place an object here, and you place an object here. The object here experiences lesser pressure. Just this one, a greater pressure, and this, a far more greater pressure. So what this simply tells us that in a fluid, the pressure at the top is lesser or equals to the atmospheric pressure. As we go down gradually, we move down gradually with an increase in height. The pressure at depths are greater than the pressure which you find above the surface of the liquid. So pressure, another property, pressure does not depend on the surface area in contact. Like I said, it transmits the pressure equally in all directions. It doesn't depend on the area in which it is in contact with. Pressure does not depend on the shape, the volume. Pressure has to do with the fluid itself. So quickly, I'll be looking at applications of pressure. First, we have an hydraulic press. Now, what is an hydraulic press? It's a simple device which has a piston. It has a piston and a larger piston and a smaller piston. So the mechanism is very simple. It's based on Pascal's law, which says that pressure is transmitted equally. So you have two containers like this, and you have a connecting tube here. The diameter here is larger than the diameter which is here. Okay, so an application of a pressure force here, force which is transmitted equally. The pressure force is also transmitted through this tube equally also to this smaller piston. So the pressure is transmitted equally. So also we have a car brake. So the same principle which an hydraulic press operates on is also what a car brake operates with. So in a car brake, you have the brake pad, and the brake pad is connected, a series of connection to the tire. So what simply happens is that on pressing on this brake pad, a piston in the engine, the mechanical system of the car, is being called, to transmit a fluid. A fluid is being transmitted through this line down to the brake pads of the tires, the brake pads, which makes this tire to stop. So this brake pad is a continuous system. You have 4 wheels in a car, and the first 2 tires consist of the brake pad. So this brake pad, on applying the pressure on it, it transmits the fluid and balances the brake system of the car, which brings the car to a halt. So this is also as a result of pressure. We also have a siphon, we have a syringe, and we have pumps. So in a syringe, you have a syringe which is used to draw blood, draw samples, or is used for drawing anything. It can be fluid, it can be air. You have different types of syringe. So what simply happens is that inside the syringe you have something like is a piston-like device. So on applying force, the piston absorbs liquid. Let's say we are drawing blood from a patient. On pressing the syringe, the piston, as a result of the pressure force, it absorbs the liquid, and on releasing, it begins to balance and fill the container. So what simply happened in the syringe is that once you push this syringe forward, the pressure is moved out of the tube, which makes the liquid inside the tube to move out, and vice versa. So this is also as a result of transmission of pressure. And also you have pumps. In pumps, you want to pump a tire, you apply a certain amount of force, and you have a hose which pumps the tire. So what simply happens is you apply a force here, which is transmitted equally, and which begins to pumps. So we have different application. You can have bicycle pumps, you have water pumps, you have even your jack, the jack of a car. It also works as a result of the principle of pressure. So quickly we'll be looking at some examples. So here it says, what will be the pressure due to water at the bottom of a reservoir which is 20 meters deep and 4/5 full of water, where the density of water is 1000 kilogram per meter cube, and we are given the acceleration due to gravity as this. So as usual, when you want to solve questions in physics, you need to state out the parameters you are given. So we are given that we are given a reservoir. We are asked to find the pressure due to water at the bottom. So we are asked to find, this is water in the reservoir. We are asked to find the pressure due to this volume of water. We are told that the reservoir is 20 meters deep, but it is 4/5 full of water. So what this says is this reservoir is 20 meters deep, but the volume of water occupied is 4/5. Also, we are given the density of water to 1000 kilogram per meter cube. We are given a solution due to gravity 10 meter per second square. So we've been able to state out the parameters given, and we are asked to find the pressure, which is an unknown, which can either be in Newton per meter square or in pascals. So recall from the formulas stated, for solids you have pressure as force over area, and for liquids you have pressure as density multiplied by gravity multiplied by height. So we'll be using this. We have the density, we have gravity, but we need to find the height. Recall that the tank is 20 meters deep, but the volume of water occupied is 4/5. So we need to find the height of water. So this gives 4/5. We are told 4/5 of the tank, the height of the tank, which is 20 meters. So this gives us 80 over 5, which is just 16 meter. So we can use our formula, which is pressure is equals to the density, which is 1000, gravity, which is 10, and our height, which is 16. We have 1006. So that gives us 1, 2, 3, 4, 1, 2, 3, 4. So you have 160,000 pascals, which can also be 160 kilopascals. Also, we have a second example here. It says a large circular piston of radius 1 meter exerts a force of 100 Newton on the circular plunger in a hydraulic press. You can recall that one application of pressure is in hydraulic presses. So we have to find the force exerted on the plunger. So the first thing to do, as always, is to try to interpret what the question tells us. So we're told we have a large circular piston. So let's say this is our piston. So we are told that the exerted force on the plunger. So let's just say this is our plunger. Okay, so said a large circular piston of radius 1 meter exerts a force of 100 Newton on the circular plunger. Find the force exerted on the plunger. So this large piston has a radius. The radius here, the radius of the piston, which is 1 meters, exerts a force. The force which is exerted on the piston is 100 Newton. So we have to find the force which this little piston, which is the plunger, exerts. Remember that pressure is transmitted equally. On exerting a force here, the fluids here have movements, they are under high pressure, so, and they transmit it through this tube to this place. So what simply happens is, as this force compresses this force, this piston tends to move inwards. So as the pressure is transmitted here, the plunger, this piston here, moves upward due to the increase in pressure. So we're going to recall that pressure is equals to force over area. So this was the principle you're going to be using here. So for the piston, the force in the piston, the pressure, in the piston, that's F over A. And for the plunger, the pressure also is force over A. So we have to use small letters because they are different. So as a result of Pascal's law, which tells us there is equal transmission of pressure in every direction, so the pressure force in the piston should definitely be equals to the force in the plunger. The force in the piston must be equals to the force in the plunger. Okay, so if that is the case, so we need to find we have to find the force exerted on the plunger. So we are looking for small f over A, small f over A. Okay, so this plunger also has its own radius. Forgot to add. Its radius is 0.2 meters. Okay, radius. Okay, so recall that we are told it is a piston. So a piston is something like this. That's a circular top. So I was just using that illustration to explain how the pressure force is being transmitted. Yeah. Okay, so the area is equals to pi r squared, the area of a circle, which is pi r squared. So for the piston now, we're told the force on the piston is 100 Newton. The area of the piston, which is pi multiplied by the radius. We're told the piston has a radius of 1 meters. That's 1 square equals to, we don't know the force on the plunger. We can find the area of the plunger, which is pi times 0.2 square. So we have this is the relationship we are using. So we have 100 over pi. Okay, so what I simply want to do here is to do a change of subject. So I'm doing a change of subject. We're going to be having F is equals to, so from here, so F is going to be equals to, sorry, you have F over A. I'm going to take it bit by bit now. Multiplying these two together, you have F multiplied by small f multiplied by big A. F will give us big F multiplied by small a over big A. Okay, so we have this F multiplied by A, small f multiplied by big A. So small f is going to give us F multiplied by A. It's going to be F multiplied by A. This. Sorry for that. So another way to that, we have F over A, small f over A. Multiplying this, we have F multiplied by small a equals to small f multiplied by big A. So we can see from here that big F over F is equals to big A over A. So these are various ways in which can determine the relationship. So having figured out the relationship between the values, you can now continue solving. So we have 100 over small f to be pi multiplied by 1 square, pi 0.2 square, 100 over f gives us, analyze this on the calculator, it's going to give us 25. So we have f times 25 equals to 100. F gives us 4 Newton, which is the force on the plunger. So you can quickly do a quick check to check if we are correct. We are told that the force in the piston should be equal to the force in the plunger, and this is a check. The piston, which is F over A, plunger, which is small f over A. The force in the piston, 100 Newton. The area of the piston, pi multiplied by 1 square. The force in the plunger, which we just got as 4. And the area of the plunger, which is pi times 0.2 square. Okay, so we have 100 over pi times 1 square to give us 3.142. We have 4 over this. And pi times 0.2 square should give us 0.125. I say 68. 100 divided by 3.142 should give us 31.83. Also 4 divided by this gives us 31.83. So this proves Pascal's law. The pressure transmitted is equal in all directions. So the same pressure transmitted from the piston moves to the plunger. The same pressure which moves both ways. Thanks.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.